going to talk about type 1 and type 2 errors. So before we get into the test, I want to just first talk about the difference between a type 1 error and a type 2 error. So a type 2 error or a type 1 error can only happen if you have rejected the null hypothesis, but for some reason, not because of math, but for some reason, maybe a small sample size, maybe some kind of a bias in your data, or simply just not enough data, so a small n, a small sample size, it really isn't the correct conclusion. We can also have a type 2 error. A type 2 error, it's really the same error, but it occurs when we fail to reject. So if we fail to reject the null hypothesis, but for similar reasons, some kind of a bias in our data, a small n, it really isn't the correct conclusion. So let's go ahead and test number 1. I'm just going to do some really quick hypothesis tests so we can get to talking about the possible errors that we have with this information. Okay, so number 1, the average income of an NFL football fan is reported to be $51,371. Just Googled that. We think that the average is higher than this, so we surveyed fans at an NFL game. The average income for 103,000 some turned out to be 222,000 with a standard deviation of 3782. Can it be concluded that the average income of the fans is higher than that was reported? So let me run through our 4-step p-value test here. So either the mean average is that 51,371 that was reported, or like we're thinking it's higher than 51,371. Step 2 is the p-value. I'm going to let my calculator do the work here for my p-value. So I'm going to go right into stat and then tests. We do not have a, whoops, let me go back, because we do not have a population standard. Oh no, we do have the population. We don't. So here, this 3732, that was for our sample. So we only have the sample standard deviation S. So when I go over to tests, I need to choose a t-test. No population standard deviation. Okay, so t-test. I do have stats, don't have data. The hypothesized average is 51,371. And the sample mean that we found was 222,318. And we decided that was a sample standard deviation of 3782, with a pretty big sample size there of 103,219. We think it was higher, so I'm going to choose the greater than symbol here. Oh, whoops, did I just hit clear? Do it one more time. Hopefully it remembers some of it. So t-test, and sure enough it does. Let me just go down and choose greater than, hitting enter, and then calculate. Okay, so we end up with this p-value that is 0. So that's a really, really, really small p-value. So my p-value is approximately 0. So for this one-tail test, we had a rejection region that was 0.01 in area. The area that we found for the p-value, so this p-value area, I don't even have anything to fill in, right? It's 0, or if we even just say it's really tiny and a little bit more than 0, and I were to shade something in, it would be the tiniest little speck over there in that rejection region. So we definitely, without a doubt, reject the null hypothesis. So step number 3 here, we're going to reject the null hypothesis, which means that we're concluding that the average income is higher than that was reported, is higher. Okay, so we're talking about errors here. So what if I told you something interesting about this sample? So this sample of 103,000 fans happened to be at a Super Bowl. So yes, it was an NFL game. Yes, we asked them for their average income, but this is an average from a Super Bowl. And this was actually the average income from a Super Bowl in 2007. So we would expect, people that attend the Super Bowl to have a much higher income than just your average everyday NFL football fan. So was there a type 1 error here? I'd say, yeah, absolutely. So we've committed a type 1 error. We have a valid conclusion based on the math that we created, but we do not have a valid conclusion based on the bias in our sample. So we had a pretty big bias in that sample, so we would say that there's a type 1 error. Even if I didn't tell you that this was the Super Bowl, even if you didn't know enough about the data, you would just say that there's a possible type 1 error. So certainly there's one possible. Knowing that this was for a Super Bowl versus just all of the fans, it's not just possible, it's very probable. Okay, so that was a type 1 error. We rejected when really we had a bias in our data. Let's take a look at another example. So this one is example number 2. Can I get at it here? So with example 2, there we go. So with example number 2, we have the average age of a college student in the US, again, I just looked this up on the internet, is 22.7 years, with a population standard deviation of 1.1. We surveyed 67 students and found an average that was pretty close, so 23.1 years. Can it be concluded that the average age is significantly different? Okay, so again, I'm going to run a p-value test. We need a null and an alternative hypothesis. The average age that I found there on Google was 22.7. We're just wondering if this is different, so not equal to 22.7. So we've got our survey here of 67 students, but the standard deviation that we were given belongs to the population. So we do have a population standard deviation, so we can go ahead and run this one as a z-test. I'm going to do another p-value, so I'm going to look for that p-value area, that rejection area, so we can compare it to, this one was 0.05 two-tail test, so that rejection area of 0.05 is divided into 2 tails. Let's go back to stat and then tests. We're running a z-test this time. With stats, 22.7 is the average age I found online with a population standard deviation of 1.1. The average age that we found at WVC was 23.1, and 67 students were in that survey. And we just want to know if it's the same or not, so we're going to choose not equals here. That looks good. I'm going to go down here and calculate. So we found a p-value area of 0.0029. So our p-value area is about 0.0029, a very, very small p-value area. This p-value area is less than the significance area of 0.05, so this one does fit, and then we would say step number 3, we reject the null hypothesis, and then step number 4, is it significantly different? Well, since we rejected the null hypothesis that said the same, we would conclude that we have enough evidence to support the claim that the age, the average age, is significantly different. So we don't really know much about our data here. We don't know if this really is a valid data set or not, but we do know that we rejected, so we know that we've got a possible type 1 error. We rejected, and whenever we reject, we have a possible type 1 error. I want to actually redo this one, and I'm going to change my data just a little bit so that we end up with a slightly different conclusion. So let me just arrow this up here. I'm going to change my data. We're going to run the same one, but let's just change the data a tiny bit. So we're going to have the same hypotheses, just kind of do a do-over here. So same hypotheses, either equals 22.7 or not. But in this case, we are going to use, a population standard deviation, so of 2.2, n is still going to be 67, and our average age is 23.1. So let's say that this was the information that we were given. We still have this survey of 67 people, average age of 23.1. Standard deviation now is different. So let's say that the population standard deviation we were given is different. Still, we're going to be running a z-test. So let's redo this one. Step number 2, let's look for that p-value area. And we're still going to be comparing this to 0.05. So alpha equals 0.05. So I really don't need to change much. So if I go through and I go to tests and then z-test, 22.7, that stays the same. But we're going to assume we've got a different population standard deviation this time. Everything else stays the same. Go ahead and calculate that. This time we're given a p-value area of 0.1367 if I round. If I compare that p-value area to the area of my rejection region, 0.05, I definitely spill into the fail to reject region. So if we change this just slightly, I'm just giving us another example, my p-value area is bigger than the rejection area. So in this case, I would fail to reject the null hypothesis. And my conclusion would be that the ages, so that the average age is not significantly different. I'm just going to say SIG, so not significantly different. So in this case, with just that minor change, we failed to reject. Whenever we fail to reject, there's a possible type 2 error. Rejecting, we have a possible type 1 error. Failing to reject, we have a possible type 2 error. So if there was some kind of a bias in the data, we can kind of think that through. Several different reasons, right? And we can attach these really to both of these possible errors. 67 out of a college that has over 4,000 students is a pretty small sample size. So small sample size might be attributed to that. Also here at the college, we have a wide range of ages, so it really depends on when these 67 students were surveyed. Did we have a lot of our high school students that are taking Running Start classes? Did we have a lot of our students that take our evening classes, maybe a lot of our older classes? So we may have had a biased data set. So it could be that this data set, we failed to reject, we said it's about 22.7, but maybe it didn't include many of our older students. So maybe it only included high school students and traditional college students and, 20-somethings. So without actually knowing the data, so with the homework questions, it can be really challenging. So really what I want you to pull out of this is if you fail to reject, you have a possible type 2 error, and you've got to think through what could be wrong with my data collection, what could be wrong with the variability within my data. Then if we scroll up to this similar example that we just did when we rejected, whenever you reject, you've got a possible type 1 error, also for similar reasons.